All right, Math 2. This is Mr. A. I'm going to make this review video. This is the final exam practice, part 1. And this document is available on Canvas. I also emailed it to you right here. And let's just get into it here. Here's going to go over this. You will have the calculator for the whole exam. But I'm going to try to do these so you can watch these at home without a graphing calculator. Just see what you need to do. So let's check it out. Let's get into it. So the first one here is one of those simplify the expression, and this involves the rules of exponents. Now you have an exponent on the inside here, and don't forget you have 3 to the first power in here, and you have an exponent also on the outside. So you know the rule here is this. You know that this exponent is just going to multiply the other exponents on the inside. It's kind of like distribution, right? So you end up with 3 squared, 3 times 2, that's x to the 6th power. And then we have y, 5 to the 10th power. And 1/2 times 2 is just z to the 1st power. So that part is simplified already. Now, the other part it's multiplying by here is the third root, right? And remember, if you have a third root, any type of time you have that radical here with a number, the only one where you see a radical without a number is the square root, but this has a 3 on it. So remember, that means that the whole thing inside of the root symbol there, inside of that radical, is raised to the 1/3 power. It's a fraction exponent. Now, at this point, you just do the same thing we did in the previous section of it here. You take that exponent now, and it multiplies all the exponents of the values that were inside the root symbol. So you end up with 64 to the 3rd power. What's 2 times the 3rd? Well, it's 2/3. 3 times the 3rd is y to the 1st, and that's a 1 on there in that z. That's z to the 1/3. Remember, if you have a letter or a variable or a number with no exponent, you assume it has an exponent of 1. So there it is. All right, so it's multiplying on this thing right here. So there it is. So now we got to multiply these things. At this point, y'all know 3 to the 2nd power is 9, but 64 to the 1/3 power, well, let's move this over a little bit so I have some room. 64 to the 1/3 power, that's just what value times itself 3 times makes 64. And here's a little extra practice here. I know this. I'm going to do that 64 separately right here. I'm without calculator, watch. I know that 64 is 4 times 4 times 4. Right? Does that make sense? 4 times 4 times 4. And if I were to, it's 4 to the 1st power each time. If I were to put a 1/3 on each of those, we have 4 to the 3rd times 4 to the 3rd times 4 to the 3rd. It's like extra review about exponents, really. And you remember when you're multiplying values with the same base, you add the exponents. What's 1/3 plus 1/3 plus 1/3? That is 4 to the 3/3. So that's how it works, really. So the third root of 64 is 4, because that's like 4 to the 1st power, right? So that's just to show you some extra steps there. Or you can use your calculator. Doesn't matter. You put 64 to the 1/3 and you'll get 4. Okay. Now you know 3 squared here is going to be 9. 9 times 4, you know, is 36. Immediately, check your answers. And sure enough, the only one with 36 as a coefficient is A. So your answer is probably going to be, it is. Your answer is A. They'll do this on the exam. They'll kind of fool you with like 2 128s here. Oh, it must be one of those, you know. They wouldn't give it to you that easy. But sometimes they do. Always check your answers within the steps you do. But let's complete this to understand how we get the rest of these. So remember, when you are multiplying values with the same base, that's when you add the exponents. So we know that we're going to have x to the 6 plus 2/3. And we're going to have y 10 plus 1, because we're adding the 10 and the 1 here off the y, right? And we have z 1 plus 1/3. Well, here's a little fraction review for you. You can use the calculator and add it in the calculator, no problem. But 6 plus 2/3 is like 18/3 plus 2/3, right? Because 18 divided by 3 is 6. And then you end up with 20/3. That's how you get that 20/3 in the answer. 10 plus 1 is easy. That's y to the 11th. And then 1 plus 1/3 is 3/3 plus 1/3. That is z to the 4/3. So that's how you do it. Remember, when you're multiplying values with the same base, you add the exponents. Where'd my 3 go? And there it is. All right, let's move on. Joe Schmo's a swimming pool. Length of the pool is that. Width of the pool is that. Which one of these measurements of the pool of the they're asking for the third measurement of the volume because we have length, width, so they're obviously speaking of the depth or the height of the pool, right? Because volume is length times width times height. So which one of these will result in a rational value? Remember what an irrational value is: the square root of an imperfect, non-rootable number like like 10. Square root of 11 is irrational. Square root of 15, that's irrational. Square root of 16, nope, that's rational because that's equal to 4. Non-perfect squares, basically. That's what it is. So we're trying to find which one of these are we going to multiply by these two to make a perfect square root. And you really just want to pay attention to the square root parts. You don't need to worry about those numbers on the outside. You know that those are already rational. So let's pay attention to the square root of 2 times the square root of 3. Now we're going to try these other ones out here and see which ones. That's a square root of 3 right there, see it? We're going to see which other one would make a square root, a perfect square root. So that's square root of 6 so far. Which one of these numbers that I highlighted multiplied by 6 is going to make a perfect square root? Well, 6 times 3 is 18. Square root of 18, if you were to use that one, no, that's not rational. Square root of 18 is a weird number. How about 6 times 7? What's that? That's square root of 42. That's not it. What's 6 times 24? 6 times 24 is 144. Oh, you know square root of 144. That means it's going to come out to be a perfect square root, which is 12. So that's our value that we want to make for our third measurement of our volume. If you were to multiply that value and that value and that value all together, it would make a rational value. That's right. And don't forget, fractions are rational too. Negative values are rational. The only thing that's irrational are those square roots of strange numbers. That's it. All right, next one. Height in feet of a flying disc after so many seconds is modeled by the equation h of t. In other words, height as a function of time, or height according to time, is this value here, this function here. What does the 3 in the equation represent? Well, this one's pretty easy. This is the starting height. That's the starting value. That's where it's, in other words, that's known as the y-intercept, right? It's right there. It's at 3. So the graph is starting right there. And you know it's probably going to be some type of parabola, because that's how this does when you have a quadratic. That's the general shape of a quadratic. You know it's going to be some type of quadratic. You may be asked something different on the exam. They might say, hey, how long passes before the Frisbee hits the ground? In that case, you want to find the root, right? Those are the root, or the 0. This is the y-intercept, and that is the starting. That's the starting height. Initial height of the disk. There it is. All right, number 4 here. The function, this is changed to that form. You should recognize this form when it has that perfect little square dude in there like that, that squared value there. That's called vertex form. And to get to that vertex form, you want to complete the square. Here we go. Let's do it. All right, so I'm going to rewrite. First thing it is, you want to get this into standard form, which means that you get everything equal to 0. All right, cool. Now, to complete the square, the next thing you do is you got to get that x squared by itself. So you need to divide out any coefficient that's on that x squared. Let's divide out that 2. And it's okay to use decimal numbers here. All right, good. Now the next step is to find half of that value and add it and subtract it inside there. So here's what you'll have. X squared plus 3.5x. What's half of 3.5? Half of 3.5 is 1.75. So here's where the completing the square part comes in. You're going to add 1.75 squared, and you're going to subtract 1.75 squared. That's the part that keeps it legit. It's still, it's worth the same thing. All right, that's now equal to 0. Good. Now at this point, this is where you want to simplify it. The whole reason we did this, remember, the whole reason we did this adding, subtracting thing here is we want to be able to factor that into one of those perfect square binomials. So these two things factor into, 2 still hanging out of here, x plus whatever that half value was. In this case, it's 1.75. There he goes. Now these two here, you want to use your calculator to simplify. So here I go. I'm going to use it, even if you may not have it with you, but this is how it works. So we had negative 1.75 squared plus 7.5. And I get 4.4375. I don't like that decimal value. I think I'm going to math frack it a little bit. 71/16. All right. Plus. I like that a little better than that decimal. All right. So I write that there at the end. Now there's one more thing you got to do here. See that 2 that's been on the outside there that we undistributed before we divided them out? He's got to go back onto the front of that binomial, perfect square binomial. He's got to redistribute. So now we end up with a final value of 2. He hangs out in front of that binomial. Plus, what's 71/16 times 2? Well, it ends up being 71/8 equals 0. Now, we are now in this form. This is called vertex form. I could tell, this is a little point of review here. You can now tell the vertex of this quadratic. It's negative 1.75, remember, plus, and then 71/8 is the y-coordinate. That's the vertex. It's asking for, in the new form, though, what is the value of c? And sure enough, the c is right there. Boom. There it is. They'll do that. They'll ask you, like, what's the b value or the c value? If they ask you the a value, that's easy. It's the number you divided out from the x squared, you know. But they won't just say which one's equal. They'll say you need to change it yourself, and then you tell me the value of one of the numbers in there so they know you're really doing it, you know. Because otherwise, you just plug it in and see what matches. They're not going to do that in the exam. All right, great. 5. Homeboy Harry's going to cut a piece of paper measuring 9 inches by 5 inches uniformly. By what length should each side be shortened if the smaller rectangle he will create is to have an area of 32 square inches? All right. So he wants the area of this little piece here to be 32 square inches. Cool. So we need to figure out a little algebra here. Let's figure out a value, an expression for that length there. Well, we know that he's taken off the equal off both sides, equal measurements, right? So we'll call that x, right? And he's taken off this the same measurement as well, right? Whenever they ask for a measurement, it's the same around there. We can call it the same letter. And this is all the same measurement. That's why we're using X for all of them. True. So now we want to find some new dimensions for this smaller rectangle. Well, think about what's going on here. If the original length here was 9, how many X's are they taking off? To get to this new pink one here I highlighted, they're taking off an X on this side and they're taking off an X on that side. How many X's is that? 2X. What about this measurement here? How many X's are they taking off for that length there, or that width, I mean? They're taking off 2 X's, right? Now you know. You know that area is created by doing what? Area is just length times width. That's just the value for the length that we have so far, and there's the value for the width. Do we know what X is yet? No, but they still represent the length and width, and what are you going to do with those two things to get that area of 32? Of course, you're going to multiply them. That's what area is length times width equals 32. There it goes. Now, you could solve this the long way or the short way. At this point, you could check your calculator, go to y equals, and throw it in there, which I'm going to do right now. Or you could FOIL it out and solve it by hand with the quadratic formula if you want, get equal to 0 and FOIL it out, all this. Use your graphing calculator because you got the basic. You have your dimensions here ready to go. So there's your length times the width. So if I multiply them, check your table. What value am I looking for? I'm looking for an area of 32. All right? So if I cut off 0 inches, that makes sense, because what happens if I don't cut off any? I have 9 times 5. If I don't cut off any, I have 9 times 5, right? What's 9 times 5? 45, right? Check your list. Yeah, if I cut off 0 inches, there's 45. Now I'm trying to get to 32. And look what happens. It jumps to 21 is my area. So somewhere between 0 and 1. Which one of our answers is between 0 and 1? I only see one of them. And it's that one. That's the correct answer. But just to be sure, let's make sure we see how to do this in the calculator. Let's reset our table to do something different. Let's have our table start at 0.5. And instead of it going by ones, you can have it go by 0.5. So check them all, you know. See what we got at 0.5. There it is. 0.5 is definitely the correct answer. They cut off 0.5 inches from each side. And there you go. 6. Highlands newspaper charges $5 per square inch of advertising. Okay. Joe has $400 to spend. Height of his advertisement will be 4 more than the width. Okay. So, it's a rectangle, right? Cool. And you know that the height, if the width is x, then the height is going to be x plus 4, correct? So let's make up a formula of the cost of this. Okay, he has $400. He needs to stay under $400, right? So you know that the area is going to be x times x plus 4, right? That's what the general area is, no matter what you plug in for that width. Now, it's asking, here's a trick question. It says, what's the greatest height he can make? So don't forget the height is that x plus 4 thing. Is this one over here. Okay. So, let's make up a formula for the cost of this thing. So the cost, it's going to be the area in square inches, right? Times, how much is it per square inch? There it is. $5. All right, so you're going to do area times $5. Cool. All right, and the area we know is hooked up for us. We have x times x plus 4 times 5. That's our cost of this piece. So now let's just look and see in the calculator what our costs are looking like. So you throw it in there. You have x times x plus 4 times 5. Now remember that x is the width, it's not the height, so be careful. All right, let's see here. If we make the width 1, 25 bucks, all right. Oh, that's too much. What's the one? Let's put the table back to going by ones. Start at 0, going by ones here. All right. Which one can I ask for before 400? Oh, there it is, 7. 7 is the highest number before it goes over $400. There it is, right? Because this is the cost function. All right. So x can be 7 according to the formula. Now some of y'all are like, oh yeah, cool, there it goes. Yeah, I got an A, baby. No. Remember, that's the width. It's asking what's the maximum height. So if the width is 7, then the height could be 7 plus 4, which is what? 11. 11 is the maximum height. That's the correct answer right there. All right, number 7 here says, which equation below models how much hours a person works in a week? H, if they make $8.50 an hour, and their weekly paycheck amount is P. Well, you know that this makes sense. We know that you're going to get paid $8.50 times how many hours you work. Now, what they're doing is they want to know H by, they're solving for H, right? But does that make sense? You get paid $8.50 per hour. So all you got to do here to solve for H is pretty simple. You divide over $8.50. And that's it. Hours is equal to pay divided by $8.50. That one might have been too simple for a review question, but there it is. They might have something like that. All right, next one. Which expression is a solution to the equation shown? Looking at the answers, this is going to be one of those you got to use quadratic formula. They're going to have one of these on the exam. So you got to know your quadratic formula. If you don't know it, write it down now or watch. You know this one, though. Negative b plus or minus square root of b squared minus 4ac. You got to have this memorized over 2a. This will not be on any formula sheet. You got to know it. All right. If you don't know now, well, know it then. So first thing you need to do is, of course, is get this equal to 0 before you use the formula. So I'm going to subtract over the 8x, add over the 9. So we have 4x squared minus 8x, excuse me, plus 9 equals 0. Okay. And at this point, it's just plug and chug to see what you get. All right. So the b value is negative 8. I'll write them out here so you get them nice and organized here. The a value is 4. The b value is negative 8. C value is 9. There you go. And here we go. Negative 8. Oh, that's going to be positive. B squared, that's 64. I'll do it in my head. Minus 4 times A times C. 4 times 9 times 4. That is equal to 144. All right. And 2 times A is 8. Okay. So let's simplify this up a little bit more here. Clearly that's 8 plus or minus 64 minus 144. That is the square root of negative 80. Whoa. Now at this point, you're like, that does not match up with any of those. We have got to figure out a way to simplify that square root. Now this comes down to the simplifying square root exercise we did a few weeks ago, where you want to find the highest perfect square that divides into 80. And there's a negative inside there too, so you know that imaginary number business is happening. All right. So you'll have your calculator to do this. I'll tell you what it is now. So the 80 splits up into, negative 80 I should say. We have negative 1 times 16 times 5. 80 is divisible by 16. That's the highest perfect square that goes into 80 is 16. 4 goes into 80, but another 4 goes into 80 as well. So that's it. All right. Now let's break this down. If you have the square root of negative 1, that comes out as I. Don't worry, we'll talk more about that during Math 3. There's a lot more to it than that. But for right now, square root of a negative value, I. Square root of 16 is 4. And the 5 hangs out. So you end up with this. Still doesn't look like any of the values in there. Well, there's one more step. We got to simplify that fraction now. So everything divides down now. Let's divide these values right here by 4. Let's reduce them. What's 8 divided by 4? You end up with 2. 4 divided by 4, that's 1, so that's just 1i. Root 5. 8 divided by 2. Now that one is one of those problems right there, one of those answers. So it's asking, which one of these is a solution to the equation shown? Well, it's 2 plus or minus I root 5 divided by 2. And this is the only one right here that has a root 5 to it. Because the 2 ends up being positive, because remember at the beginning we had that negative 8. Answer here is B. All right. Next up, we got this another area formula. So you know we're going to be doing some type of multiplying here. So it tells us there's an area of a trapezoid. It tells you straight up the formula. It's nice. And down here it says if the area of the trapezoid is 16 square inches, okay, and B1 is equal to the height, and B2 is equal to the height plus 12, what is the value of H? Okay, so let's just plug in what they give us. Area was, it said 16. 1/2, okay. H, okay, so height's already in there. Said base 1 is equal to the height. Okay, so another H goes there. That goes for that one. Plus, and base 2 is equal to height plus 12. Okay. No big deal. You just throw it in there. So what? No big deal. Now, at this point, you're solving an equation. You're solving a quadratic equation. That's what it is. So let's simplify all this up here. We have 1/2 is chilling. All this simplifies up into 2h plus 12. That's being multiplied by an h and by a half. Okay. So it's all going to multiply out. So we end up with 1/2. I'm going to do it step by step just to make sure we see it. H, that's times 2h squared plus 12h. And 1/2 times all those is h squared plus 6h equals 16. Now what you can do is you could throw this part into the calculator and see what value for h will equal 16. And whatever our value is, and check these values. I'm going to solve this a different way. I'm going to solve this and try to factor it and solve it in that way. See what I get here. All right. So I'm going to bring the 16 over, subtract it over. H squared plus 6h minus 16, because you subtract 16 from both sides. Cool. And then, see what we got here. See if I can factor this. What times what makes h squared? H times h. All right. Anything that makes negative 16 that equals positive 6 when you add them, I'm thinking 2 and 8. I'm thinking plus 8 and a minus 2, right? Does that make sense? Yeah, it does. 8 plus negative 2 makes positive 6. And now to solve quadratics, in this method, you set each of those factors equal to 0. All right, let me hook that up. So at that point, you just set each one equal to 0 and solve it like good old algebra. H minus 2 is equal to 0. H plus 8 is equal to 0. Oh yeah, H equals 2. And H equals negative 8. Now here's our two values. You know how they have 8 up in there? They're trying to fool you. Sometimes people will solve it by factoring and be like, oh, H plus 8, yeah. The answer must be 8. No. The answer here is 2. 2 is the correct answer. 8 is not the correct answer. There it is. How can you have a height that's negative 8? That don't make no sense. The answer here that makes sense, the proper domain is 2. All right. All right, number 10. What is the sum of the y-coordinates of the solution to the system of equations? Oh, okay, so you got to find both coordinates where they intersect. Or you solve it with quadratics. You can either graph these in the calculator and see where they intersect, or you could solve them algebraically. I'm going to do that. So your first step, no matter what, even if you already use the graphing calculator, you got to get them y by itself. So we have y by itself for one of them. Okay, cool. Now the other one, we have x minus y equals negative 2. What I'm going to do is I'm going to add the y over to get it positive, and I'm going to add the 2 to that side. All right, so these cross out here, they cross out here. So you end up with y equals x plus 2. Okay. So we're trying to find the solutions to both of these. As I said, you could graph them in the calculator. But what I'm going to do is this. If y is equal to that, and y is equal to that, to solve them, you could set them equal to each other. And it's basically the same thing. So let's set them equal to each other. And then solve it with quadratics. That is the solutions, is trying to find the value for x that makes them both equal. All right, so there, I set them equal to each other. Now I'm going to make it equal to 0, which you should always do when you're solving quadratics. I'm going to subtract over an x, okay, and subtract it over the 2. All right. 8 minus 2 is 6. Negative 6x minus x is negative 7x. Now, I think I could solve this by factoring again. Are there values that can multiply to make positive 6 and add up to make negative 7? Yeah, there are. Check it out. X minus 1 and x minus 6 equals 0. Hey, that's legit. All right, so from that point, set them each equal to 0. You know that x is equal to 1 and x is equal to 6. Those are the solutions. But wait. The question is asking, what is the sum of the y coordinates? Okay, these are just the x coordinates that we found out. So to find the y coordinates, you just plug them into one of the ones we solved up here, made y equal by itself here. I'm going to pick that one, seems easier to do. So y is equal to x plus 2. Therefore, according to that, y is equal to 1 plus 2, and this, the coordinate for this one, the y coordinate for the x equals 6 is, or the domain value 6, is y equals 6 plus 2. So that y coordinate is 8, and that y coordinate is 3. And it's asking for the sum of both of those, and it is 11. Just let me show you really quickly on the graphing calculator as well. After I get y solved by itself, and what was it? X plus 2. So there's your solutions right there. We said what? 1 and 3? 1, 3, there it is. And the other one was 6, 8. 1, 2, 3, 4, 5, 6, and 8. You hit trace. Yeah, around there. You see them. You can hit second calculate intersect if you want to try it. 5. First curve, enter. Second curve, enter. And kind of show where you want to look at. There it is. 1, 3 is the one intersection. Second calculate intersect. First curve, second curve. Now this one's up here. And hit enter. 6 and 8. And they want you to add up the y coordinates. All right. Anyway, moving on. So it gives us values for this function f and function g. Okay. There it is. It's 2 times square root of x minus 4. And g of x equals 5 divided by x. Okay. It says approximately what value for x will they be equal to each other. So basically you want to look and see which one of these will make the functions equal. Well, in this case, you want to use your calculator. And anytime you have functions like where you're setting things equal to each other, anytime you have something like this, and this is algebra we will be learning in Math 3, but right now, you can use your calculator for it. When you have something like on both sides, looks complicated, go to your calculator, and you throw it in the y equals. And you're going to see where they intersect. Or you could check your table. This one I'm going to do on the table. So I'm going to put 1 and 1 y equals 2 square root x minus 4. All right. And then 5 divided by x. Check your table. And we want to see which one of these values for x makes them approximately equal. So let's check out 4.33. Now you know 4.33 doesn't just show up on the list here. We got to throw it in. Second table set. 4.33. See if that's what it is. I mean, they look pretty close. They're looking close. Now, of course, these are rounded values, so you don't know. Let's check 5.05. No, they're not even close. How about x equals 0? I don't think so. Table set 0. Nah, that's errors. And -6, it's right there. Nah, error. I'm thinking the value that we're looking for is 4.33. Let me show you the other way to do it. You graph them. There's a square root one. Here comes that weird one, the inverse function one. So about right there, see my arrow is? 1, 2, 3, 4.33. You can even check it. Second calculate intersect, 5. First curve, dang it. Second calculate intersect. Hit the wrong value. First curve, second curve. Where's the first curve? Hey, it ain't showing up. There he is. First curve, second curve, intersection. X equals 4.332. There it is. All right, there you go. So whenever you're trying to find set them equal to each other, just put one in y1, put that one in y2, and see where x makes an equal output. All right, let's keep rolling here. Match up the transformation with its description. So these are different transformations here, like on geometry, like when we're transforming triangles and whatnot, has the vertices here. So the first one, they're adding 6 to x and subtracting 9 from the y coordinate. Which one is that? I'm thinking it's this one. It's the only one with 6 and 9 in it. It's true. Which one is it where they switch places? Well, when they rotate 90 degrees, they switch places. But don't forget, when you rotate 90 degrees, they're also changing the sign of one of the coordinates. So it's not the rotate 90 degree ones. What's the only other ones where they switch places? That's over y equals x. So this one is D. All right. True. You remember this, like y becomes the x. Remember that, y becomes x. All right, where's the one where they switch places, but only one of the coordinates changes sign? That's going to be a 90-degree rotation. See how they switch places, but only one of the coordinates changes sign? That's one of those 90-degree rotations. But which one is it? Well, let's figure it out. Say we're starting over here with, I don't know, 3, 5, whatever. Say we go 90 degrees clockwise. Well, they switch places. And which one became negative? That one became negative, right? Because we're in quadrant 4 now. So that's clockwise. So transfer that idea to this code here, they tell you. That x coordinate goes, see, look right here. I'll highlight the x coordinate started here positive, and it went over there and turned negative. So this one, that's looking like it's going the other direction because the y coordinate gets a negative, and that makes sense after it switches. So that's counterclockwise. That's F right there. All right, cool. Here's one where they, number 4 here, they stay in the same place, but the y just turns to its opposite sign. Which one makes that means it's some type of vertical movement happening, right? It's a vertical movement, that's a reflection. Which one's a vertical reflection? Over the x-axis. If you move over the x-axis, it's a vertical reflection, see? Vertical. All right, that's it. How about this one where they stay the same place? Now the x turns to its opposite sign. That's a horizontal movement. That's a horizontal reflection. If you're reflecting horizontally, you're reflecting over the y-axis. That is E. All right. This one, they switch places, but both signs turn negative. That's C right there. True. And last but not least, they are multiplying both of them by another value called k in this case. Clearly, when you multiply both coordinates, you're doing a dilation. That is A. So the only one they left out here was the 90-degree rotation clockwise. That one was not used here. All right, there you go. Let's keep doing it. Baseball's hit is height in feet according to time in seconds is given in the function. Okay, an easy one here. As time clicks, the ball is going to travel probably in a parabola and gain height. It's going to gain height and then lose height. All right. How many seconds pass after it is hit does the ball begin to decrease in height? Okay. So here's our general graph, right? Starting at 3, because that's the y-intercept from that previous question. Okay. And after so much time, after time is going on, it's going to gain height and then start to fall. I'm thinking they want to find that vertex right there, right? At what point, at what time does that ball reach its highest point and then start to go down? Well, it seems to me they want to find the vertex. They want to find the input for the vertex there and see what it is. Okay. Let's try it out. You could put this in the calculator and try to find where the vertex is. I'm going to do vertex form. So I'm going to divide out that negative 16, no problem. That's t squared. What's 100 divided by 16? Oh, I don't know. 116ths. What? T plus, oh, that turns negative because you're dividing out a negative, so that turns into minus 3/16. Okay, no big deal. Now, what is half of 116? Let's see if we can reduce that. What was that? 58ths, 25/4. Okay, so you have negative 16 t squared minus 25/4 t minus 3/16. All right. So what's that half value of 25/4? What's half of 25/4? Well, you multiply it by a half. It's easy. Here it is, negative 16 t squared minus 25/4 t. Now here's the half value here. Let me change pen color so you see it. I'm going to add negative 25. What's half of 25/4? 25/8 squared, and subtract negative 25/8 squared. Minus 3/16. Did you see what I did here? It's the same thing as completing the square. Got half of 25/4 is 25/8, or negative 25/4. It's just half of that. You multiply it by 1 over 2. 25 times 1 is 25. 4 times 2 is 8. So that's it. That's that half value. I'm losing here. Anyway, so now let's just factor that thing. Remember, you factor the first 3. Negative 16 is chilling on the outside here. This goes into t minus 25/8 squared. And this part here, you just simplify. And as I said, you use the calculator to do those last 2. But here's the thing. It's just asking for the input. It's asking for how much time passes before, when it hits that vertex, it starts going down. That's what a vertex is. The vertex is where it stops going up and starts going down. It's the tippy top. And we have the x-coordinate right here. We know the x-coordinate of the vertex is going to be negative, or remember it's opposite, it's positive 25/8. And I know that my answer, I just highlighted it already, I know that my answer is going to be 3 point something, because 24 divided by 8 is exactly 3, so 25/8 is a little bit more than 3. There it is. There's your answer. You don't have to worry about the rest of this simplifying part here because you want that input. Because you know that negative 16 is just going to distribute on the outside of that binomial. Anyway, but here's also how you could do this. Of course, go to your y equals and look for the vertex on that way. It's fine. But use your calculator to check yourself. Check the algebra too. You graph it. Bet you it starts at 3. Now it's going way high here, so you have to adjust your window here. Y maximum. Let's go to 50. Whoa, that's even higher than I thought it was. Let's go to 400. How about that? That will work better, I bet. And you could check the vertex. Second, calculate maximum. There it is. And of course, we'll practice on this on the review day, just to get it fresh in your head. And there it is. About 3.12 is your answer. Just like I thought. All right. 14. Here's a graph of the function. Square root of x plus 4 minus 3. All right. So there's a graph of a function here. And it says, for what domain listed below is the value of f of x negative? Remember, all the coordinates of a function can be represented with input, and the y-coordinates is the whole function. Remember that. It's an important concept of math too here. Okay, so in domain, when they ask for domain, they're asking for an x value, an input value. An input value or a range of inputs. That's what they're asking for here. Now, I know a lot of people get confused with these greater than, less than stuffs, but don't worry, just look at what it is. Let's check the first one. They're saying if the x is bigger than 0. So let's highlight on the x-axis x greater than 0. There's 0. X greater than 0. That's basically what they're saying with that. Now look at the value of the function. They're asking where is it positive, right? Oh, no, I'm sorry. It says where is it negative. It's asking where it's negative. So look at the corresponding outputs for each of these inputs. 1, yeah, it's negative. 2, yeah, it's negative. 3, it still goes negative. 4, it's barely negative. That's legit. 5 is right on the line. That's not even negative. Now look at what an input value of 6 results in. No, it goes up. Input value of 7 is positive. Input value of 8 is positive. In other words, the y-coordinate is positive. If the y-coordinate is positive individually, then you know the function is positive at that point. So they don't all stay negative for that one. Let's try another one here. How about between negative 4 and 4? All right, let's check negative 4 and 4. I'll highlight the domain in blue. Between negative 4 and 4. You know what? I think that's the one. I think that's the domain right there. Does the function remain negative the whole time? It sure does. That's the correct domain. Those are the correct x values. That's correct right there. B is the correct answer. Let's check these other ones, though, just in case, just to get an idea of what's up. How about between 0 and 8? Okay, that's all that means there, between 0 and 8. Okay. 0 and 8. No, they have some that the function is positive. All right, and then how about greater than 5? No, definitely, that's all positive there. No good. Answer is B. Find the vertex and tell whether it's maximum or minimum. Well, you could graph this in the calculator and spend your extra time, or you just look at the vertex. It's right there. It's already in vertex form. The vertex is 4, -6. So it's that one or that one. Now, the other thing to check is it a positive or a negative function? Well, in front there, it's positive, right? If it's positive, you know the graph shape is going to be like this, right? And you know that the vertex is going to be right there. It's going to be a minimum. Answer is A. All right. I think this is the last question. It sure is. Joe Schmo throws a ball in the air. The height of the ball, according to time, is represented by this chart. At the exact time Sally throws a ball as well, the height of her ball is given like this. What is the approximate difference between the maximum height of their throw? All right. This one you'll definitely need your calculator for. You're going to need your stat values here. So let's go to edit, put our values in, or the stat edit, and then here it is. So they're giving us a clue. You're going to tell the calculator to create a quadratic function. Now, how do I know it's quadratic? Let me lower this calculator for a minute. How do I know it's quadratic? You know it's quadratic because the clue is maximum. If you see a word like maximum or minimum or something like that, you know you're messing with a quadratic function. That's the clue there. All right. Stat, calculate. Tell the calculator to create a quadratic function. Number 5. Here's the important part. This is where you tell the calculator to store the equation. Vars, y vars, and it stores it for you. You can also write down the equation. I suggest that you do. All right, so I got -16. They're using t in the problem, so it doesn't matter. Plus 55t plus 6. This is this guy's function here. Now, at this point, you can complete the square for each of these to find the vertex, because you're looking for the maximum height, and that means you're looking for the y value of the vertex, which will take a lot of time. Or you could use your calculator. You told it to save it in y1, and there it is. Remember, it was -16, basically. And you could graph it and find the vertex using the function. I already see it right there. I'm going to try to calculate that vertex of this function that I saved from the chart here for... Remember, it tells you the little blinker thing. It tells you the coordinate at the bottom here. So I know it's at the origin or close to it right there. So I'm going to go to the left of it a little bit, to the right of the vertex. Kind of guess. So the maximum I have for this one was about 53.27. All right. So now you do the same thing for the other one. The other one, they give you the pattern already. No problems. You throw in y equals. And you hook it up. -16 x squared plus 52x plus 5. Graph that piece. Find out its maximum using the same technique. Second, calculate maximum. Left bound. Go to the left of it a little bit. All right. Remember, you have to tell the calculator where to look for the maximum, or it'll look forever and it'll blow up or something. Maximum of this one was 47.25. Now be careful. This x coordinate is just how long in the flight it is. That's not the maximum height. That's just the input where the maximum happens. Okay, so that's 47.25. That is for this one here. So at this point, you just find which one has the closest difference to it. 47.25 to about 53.25. That's about 6 feet difference. There's your answer. True. All right, that's it. Look for those keywords for quadratic, like parabola, maximum, minimum, roots, things of that. They'll always throw those keywords in there. And that's part 1 of the exam. Check out the part 2 video with your document, and we will see y'all on Thursday for the final review. Come with any questions. See ya.